We will start with the tree data structure, which is a nonlinear data structure. The data structures which we saw earlier, like arrays, stacks, queues, linked list, these are all linear data structures. So unlike them, tree is a nonlinear data structure. Next we will see how a tree is arranged. This shows how a tree is arranged. Each of the bubble is a node where information is stored. The topmost node is called root. In this case, it is also the parent node, and node below it are the child nodes. A node at the end and which does not have any child. These two nodes are called leaf nodes. We will see the other terminologies later. So a tree is defined like this. A tree is a finite set of one or more nodes such that there is a special node called root. Remaining nodes are partitioned into disjoint sets. For example, if you take this node A is called root, and you have disjoint sets T1, T2, T3, and each of these T1, T2 and T3 are again trees. So if you take T1 is a tree with the root B, T2 is a tree with the root C, and T3 is a root with the T3 is a tree with the root D. So generally it is defined as remaining nodes are partitioned into n disjoint sets T1, T2 up to Tn, where each TA is a tree. This is how you define a tree. Then we will see a type of tree called binary tree. Binary tree is defined as a set of nodes such that it can be empty and it has a specially designated node called root, and the remaining nodes of T form two disjoint binary trees, T1 and T2, or simply I can say that there exists a root node and each node will be having at most two children. So if you take the node 66, it has two children 54 and 75. If you take 54, it has two children 52 and 59. But if you take 52, it doesn't have any children. That is okay with binary tree. It is either empty or will be having at most two children. Then there is a concept called full binary tree. It is a type of binary tree which is full. Full means it contains maximum possible number of nodes in all levels. So which means that except the leaf nodes, all other levels are full, which means if in the case of binary tree, all the levels except the one with leaf node will be having two children. So level means the root will be in level 0, then you have level 1, level 2 and level 3. So here you will be having 4 levels, 0, 1, 2 and 3. Level starts from 0, or I can say that root is at the level 0. So in the full binary tree, all levels are full except the last one. Then we have complete binary tree. Complete binary tree is a specific case of full binary tree where all its level except possibly the last level have the maximum number of possible nodes. So, and all the nodes at the last level appear as far left as possible, which means that all the levels are full except the last one, and the nodes appear left as possible. So which means that if you have a node like this won't be a complete binary tree, since you have a child node for 7. If it wants to be a complete binary tree, the configuration should be like this. all the nodes should be as far left as possible.